What's up guys, today I'm going to be showing you how to use multiple cores in Python. Um, and this is going to effectively sidestep the GIL, which if you're watching this video I'm sure you've encountered problems with the GIL, which um, the global interpreter lock, which basically just locks everything to one core. But we're going to sidestep that in this video. So let's just get started. I've already started a new Python script and I'm using Visual Studio, but this will work for any environment that you like. So we're going to need to import some stuff. So let's import the process from multiprocessing. So from multiprocessing, import process with a capital P. And let's define our main function that we're going to be calling our processes in. So def main, define main, and then let's do the if name equals main down here. And this part, if you're confused by this and if you don't know what it means, look it up. There's a bunch of videos on what this means, but it is necessary for this to work. So you can either trust me or you can look it up if you really want to know what it means. So that, and then if name equals main, we're going to call our main function that we just defined up there. Okay, so let's put stuff in our main function. So what we're going to be doing is we're going to be basically we're going to be making processes and assigning those processes to each core, and each of those processes is going to call a function that we define. We'll define those functions later. It's going to define the function, and we're going to assign a function to each core. I'll only be using 4 cores because the code can get a little bit repetitive. So let's get started here. So we're going to define each process as a variable. So we're going to call this, I don't know, P1, process 1 equals process, and target equals, and just leave the equals part blank. We'll get back to it later. And it looks like this autocomplete drives me crazy. So let's just type that in again. Target equals, and like I said, leave that blank, and then comma args equals, and then in parentheses leave that blank as well. And we will fix that later. So we can use these processes. So we're going to need that to do that 4 times because we're going to be using 4 of our cores. So let's just do this 4 times here, and let's call it P2, P3, and P4 for each process. So let's define the functions that these processes are going to target up here. And we really can do anything. Just for the sake of simplicity, I'm going to be defining a factorial function, and you can use anything you want. But I'm just going to define a factorial function that outputs the answer to a file. I'm using factorials because we can put in big numbers and we can actually see the 4 cores being used, because a lot of times with this program it's going to happen so fast that you won't notice any change in speed unless you're using really intensive programs or processes like factorial. So let's define our factorial function. So define factorial 1, and we're going to be using 4 of these, and thus outputting 4 files. We'll output the answer to four files for each core. Okay, so let's define this, and if you want to really know what a factorial algorithm is, you can look it up. I'm just going to type this in for the sake of simplicity. Just defining a number right there that it's going to be equal to 1, and that's going to be our final answer. We'll put a while loop here, while n. Actually, we gotta take the argument. We'll just make it the number that's going to be factorialed. So if that's a word, so put n in there. So while n is greater than or equal to 1, num times equals n, and then n is going to be getting smaller and smaller each time by 1. So basically what this is doing is it's starting, okay, so let's say we want to do 5 factorial, so it's going to take the 5 up here, set this num equal to 1, and then while 5 is great, okay, so while n is greater than 1, this is going to run this loop. So 5 is greater than 1 or equal to 1. So it's going to multiply num by 5, so num's going to be 5 that now, and then it's going to make n 4, and then it's going to multiply 5 by 4, and then all the way down to where it's equal to 1. So that's what a factorial is. So that's just a simple algorithm, and like I said, you can use anything you want in this function. So, and then we're just going to output this answer to a file. So let's real quickly do that. So out file underscore file equals open, and let's just call this out1.txt. And then we're going to give this function write permission to this file, so w, and close that off, and that should work. And then we need to write the num being our final answer, so out file dot write lines, and the write lines function only accepts strings, so we're going to need to convert the num to a string, so str num, and then close those off. Alright, and then close the file. Out file dot close. Okay, and that looks good. So we're going to need 4 of those, so let's copy and paste this thing 4 times for each core. Okay, 4 of them, and we'll change the names to factorial 2, factorial 3, and factorial 4. Alright, and looks like we'll need to change the file names too, so let's change this to 2, this to out 3, and this one to 4. Good. Alright, okay, now we can use that and define these processes. So let's do that. So target equals just the function name. So for the first one, it's going to be factorial 1. And notice it's just the function name, no parentheses, just the name. And then the args, it's going to be n. And the syntax for this is a little weird since this just is one argument. This function only takes one argument. The way you input that in a process is you put the argument n right there, and then you just put a comma after it. It's a little weird, but that's just how they do it. So whatever. And then factorial 2, and then same thing. N, comma, and actually, let's not use n because we used n up here. So let's call this capital N, just so it's different. Capital N. Okay, that works. Target equals factorial 3, and args equals capital N, comma. And same thing for here, factorial 4, and capital N. And we need to define this number n, the number that we're going to factorial. So let's do that. So let's make some input here. So n equals input, I can't spell today, input, enter the integer, close it off, let's close it off, okay. And since n will be a string after we enter the integer, let's convert this to an int, so that because these arguments will obviously only work because if they're ints, because it's performing operations on them, and that only works with numbers. So after we convert it to int, that should work. There's only 1 or 2 final steps. We have to start the process and then join it to the core. So what we're going to do down here is we're going to p1 dot start that function, and then we're just going to copy that and paste it for the other processes. Good. And change the names to 2, 3, and 4. Good. And for that, we also have to do join them to the to the process to the core. So we're going to do p1 dot join and copy that and paste it for the others. And then we have to change the names. Like I said, this code can get kind of repetitive, and I know you can just annotate it and make it, just put the numbers after it in the name in a for loop or something, but we're not going to do that because I don't want to make this too complicated. Okay, so this is our program, and what it's going to do is it's just going to start these processes, call these functions, and crunch these big numbers out. And I know it's repetitive, performing the same operation 4 times, but it's just showing you that you can use more than one core in Python, which is awesome because Python is such a good language, and it'd be awesome if it used all your cores by default, but it doesn't. But that's okay. We can still do this to make it do that. So let's start this program. I'm going to use my task managers to show you the video. Excuse me. The calculations really are doing something to the CPU usage. If I can size my windows right. Sorry, it's a little laggy. All right. So we're going to run this thing, and right now my CPU is like 5% ish, and it should jump up to over 50 because I have 8 cores and we're using 4 of them. So I don't know, let's just test it out with 5, just a simple one. And we have a error. Process is not defined. Oh yeah, capital P. I said that at the beginning. I don't know why I didn't write it. That should work now. Alright, 5. Yep, good. Done. Works. So let's just go over to our project folder and view the files that it outputted. And I just reinstalled Windows, so there's not going to be very many projects in this, I don't believe. Nope, not very many. Yeah, looks like I did have another one. Okay. So those are the 4 files, and 5 factorial, that's 120, and there you go, 120. And each file has the same answer. Now, we couldn't tell that in our task manager because it's a small number. It's hard. It's not going to really show up because it performs the calculation so quickly. But let's use a big number, and we can see that it actually working. So let's use what will be a big number? 100,000. 100,000 factorial. That's a very big number. So 5 zeros per center, and it's computing through, and you can see here the CPU usage is well over 50%. It's actually using exactly 50%, and you can see these 4 processes that we started down here in our task manager, and they're using each 1 core, about an eighth of. I have an 8-core machine, so they're using about an eighth of my PC. So it looks like it's done. So yeah, our CPU usage was going to drop. So done. Let's go back to our files here and check out our output. Yep, there it is. It's a big number, and we computed 4 of them simultaneously on 4 cores. And like I said, you can do this with anything. Just fill in the blank for whatever function you want to define, and then target that with a process. And you can use it on. You can assign it to each individual core. So that's a very, very useful bit of Python. So that's about it. So thanks for watching.